12 factorial. I don't know. I have not tried. Let's see if it gives it to us. Math. We have to go to probabilities this time. And you will have the symbol in number 4. So put the symbol, choose 4. No, I didn't mean that. So let's put 12 first, and then go to math, go to probabilities, and choose number 4. 12 factorial. Let's see how big this is. Wow. So 3, 3. So 479,000,001,600. They grow tremendously. So that was just a notation. For example, if I want, let's say, to simplify 14 factorial divided by 12 factorial times 3 factorial. Which of these two is bigger? I know it's a silly question. Obviously, 14 is bigger. So all this we'll have to multiply by 13 and then by 14, right? So how do I simplify this? I don't want to put this in the calculator. But I see that 14 is bigger. I will change 14 factorial into 14 times 13. And I see the 12 factorial. I'm going to stop at 12 factorial. I should have continued, right? 14 times 13 times 12 times 11 times 10 times ... 1. But I see 12 factorial here. 3 factorial is easy. It's 3 times 2 times 1, which is 6. And that's what I wanted. And now the whole thing is very simple. I have 14 times 13 and divide by 6. Done. And that is 0.179 blah, blah, blah. Oh, how can it be? I used the division symbol twice. Sorry. 14 times 13 divided by 6. So it's 30.33. So that's the way we simplify. Now, can I simplify expressions with factorial that I cannot put in the calculator? Yes. So for example, let's say n plus 2 factorial divided by n factorial. How do I simplify this? It's not difficult. Which of these two is bigger? N plus 2 or n?
N plus 2.
Perfect. So n plus 2 will be the first. The next one I have to subtract 1 from this, no problem. The next one I have to subtract 1 from this, and I can stop. Why will I stop? Because I see this. So the simplified form will be n squared plus n plus 2n, which is 3n, and plus 2, which I cannot do with the calculator, though. So this is the factorial notation, and now we are ready for any problem you would like to look at from 29 through 42, page 752. And you choose, or I will. Okay, I want to choose 34. 34 is the sum from k equals 1 through 4, from k minus 3, k plus 2. Let's list the first and the last term, and then we'll do it with the calculator. When k is 1, 1 minus 3 times 1 plus 2 plus ... When k is 4, 4 minus 3, 4 plus 2. Can I do this by hand? Of course. You want to do it by hand? There are only 5 terms. I have to list all of them to calculate, or we use the calculator. What would you like to do? Okay, no one says anything, so I'm going to use the summation notation. So from x equals 1, So x and then 1. And the last one, the top one is 4, the upper limit. Now, I think that this calculator requires these parentheses and maybe an extra set. So careful. So x minus 3. And then in parentheses again, x plus 2. In certain situations, we need extra parentheses. Let's see what happens. So it says it's -4. We can take the time and calculate by hand. So 1 minus 3 is -2, and this is 3. -2 times 3 is -6. Plus the next one. The next one will be 2 minus 3 and 2 plus 2. So this will be -1 times 4, and -4 plus. The next one will be 3 minus 3, which will be 0. Okay, that's okay, good. So we had for k equals 1, for k equals 2, for k equals 1, 2, 3 is 0, and k equals 4 is this. So 1 times 6 indeed is -4. So that was correct. Now let's choose one with factorials. Any questions on 34? Let's look at 42. So we have the sum from I equals 1 through 5 from I plus 2 factorial divided by I factorial. Can I put it like this in the graphing calculator? Yes. Let's at least list the first and the last one. So when I is 1, I have 1 plus 2 factorial over 1 factorial. And plus the last one will be 5 plus 2 factorial divided by 5 factorial. What I would like to do is simplify this a little bit. Also, I want to mention, note, 1 factorial is 1. By convention, 0 factorial is also 1. So keep that in mind. So can I simplify I plus 2 factorial over I factorial? Yes, and I want to. So which of these two is bigger? Is it I plus 2 or is it I?
I plus 2.
Correct, and we did that a few minutes ago. So I write I plus 2 because that's my starting point. I subtract 1 from this. I get I plus 1. I subtract 1 from this, and I can stop with factorial. Why do I stop? Because I notice that these two are the same. So basically the sum is from I plus 2 times I plus 1, and we had that a few minutes ago, so it's I squared plus 3I plus 2. So by hand, the sum from I equals 1 through 5 from the simplified form will be the same as if we don't simplify. So I copy what I had, and then I'm just going to change all this inside. So it goes from 1 through 5. And that's 5, not 45, but 5. And then I can enter it as x plus 2 and x plus 1.
So I have a question.
Please.
In this case, does I still stand for imaginary numbers? Because like I know that they're
Very good question. Very good question. No. Where is that page? So I is the index, and it could be I, J, or K.
Okay.
So
I was just wondering because
yes.
I know that when I stands for imaginary numbers,
Yes.
it's like
No,
the
not
I
in this
squared,
case.
there's like something like the -1.
Yes, so I squared is -1 from complex numbers, and the square of -1 is I. No, this has nothing to do with this. It's correct, but this has nothing to do with this. So moving forward, maybe it's a good idea not ever use I, not to get confused, and just use J or K.
Okay.
Thank you for the question. Very good. So then I have I plus 2, I plus 1, or this is the same thing, and I got 110. 110. Okay. So the next step that I would like to, next type of problem that I would like to work on are exercises 43 through 49 on the same page 752. Since I see I only have like 3 minutes left, I'm not going to be able to finish. I have two other types of problems beside this one for today, and that's the end of the material for the semester. Nothing else will follow you anywhere else on this course. But I have another 15 minutes to show you a few things next Monday, Tuesday, of course. So we're asked, let's say in 43, we're asked to write this with the summation notation. So it's a sum, so I have to use the sum. So let's use from j equals to whatever till the last one from something. What do you think? I see 1 squared, 2 squared, 3 squared, dot, 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 15 squared. Where does j start according to this?
Starts at 1.
Very good. What is the upper limit for j, which I cannot go beyond?
It's 15.
Of course. Perfect. Thank you. From what?
J squared.
That's it. Done. Okay, we have time for one more. Let's say 46. In 46, we have 5 plus 5 squared plus 5 to the third plus 3 dots, only 3 dots, 5 to the 12th. They want us to write the summation notation. Let's say from k equals till the last one, and from something that represents all of them, step by step, of course, not at once.
K equals 5.
So from k equals, what changes? Not the base, right? The base does not change. This time the power changes from 1 to 2 to 3 to 12. So k equals 1 till the last one. 12 from 5 raised to k. Let's see if it works. When k equals 1, yeah, plus. When k equals 2, yep. When k equals 3, yes, dot, dot, dot. When k equals 12, 5 to the 12th.